Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 7, Lesson number 5 on factoring trinomials. Before we begin this very important lesson, let me remind you that you can find a worksheet and a homework assignment that go with this video by clicking on the video's description or by visiting our website at www.emathinstruction.com. As well, don't forget about our QR codes at the top of every page. Use your smartphone or your tablet to scan that code and come right to the video associated with that lesson. Alright, let's begin. Now, as we've talked about in the last couple lessons, factoring is really the reverse process of multiplication, which means it's quite challenging. And factoring trinomials is one of the hardest factoring processes for most students because it takes a lot of perseverance. You'll be able to do it, you just have to stick with it. And one thing that's very important is that we know how to drive this car forward before we put it in reverse. So we're going to begin with two exercises where you multiply out pairs of binomials. Okay, they're not conjugates this time, not like the last lesson. So what I'd like you to do is pause the video, multiply out these binomial pairs, and see what you get as equivalent trinomials. Do that now, choose whatever method you like, and then I'm going to go through it, okay? All right, let's multiply out some binomials. Now, I'm going to actually be going with the FOIL process. That may or may not be the way your teachers do it, but I'm going to do it for a very specific reason. So let's go ahead and take a look. Remember, in FOILing, what we're doing is we're multiplying the first two terms together. X times x is x squared. Then the outer terms, 3 times x is positive 3x. Then the inner term, 5 times x is positive 5x. And then the last two terms, 5 times 3 is positive 15. And notice that those inner two terms, the O and the I in FOIL, combine their linear terms to give us 8x and then the plus 15. Now, I'm going to rewrite the problem down below real quick because I want to point out something that's going to become essential to us as we attempt to factor. I'm going to go into a different color right now. Notice that where we get that x squared from is by multiplying these two terms, right? That's the f, the first term. Where we get, let me go with the 15, is by multiplying out the 5 and the 3. The 8x, though, that 8x comes from multiplying the 5 and the x, and the 3 and the x, right? So we get 5 times x, which is 5x, 3 times x, which is 3x, and then we add them together and get that 8x. That's extremely, extremely important to understand, all right? So I'm going to keep pointing that out in every single one in the first exercise and the second exercise. But let's go back, change our pen back to blue, and do some more products. X times x is x squared. X times 7 is positive 7x. Negative 2 times x is negative 2x. And then negative 2 times 7 is negative 14. So I'm going to get x squared. These two are going to combine to be 5x and then minus 14. Again, keep in mind that that 5x came from doing the negative 2x, the positive 7x. All right, one last one on this. We've got x times x, which is x squared. X times negative 10 is negative 10x. Negative 5 times x is negative 5x. And then negative times negative gives me a positive 50. Again, those two terms combine to give me the negative 15x. And we have x squared minus 15x plus 50. Okay? This is a very important process. All right, and these were relatively simple binomial products. In the next exercise, they're going to be a little bit more complicated, but not too bad. So pause the video now and copy down anything you need to, and make sure you understand this process, okay? All right, let's keep going. I'm going to clear this out, and let's move on to the next exercise. Again, nothing new about this exercise. You've done this before. We're just multiplying out two binomials, all right? So pause the video now, and please go ahead and do that. All right, let's go through it. Again, first, outer, inner, last. So 2x times 5x gives me a positive 10x squared. Negative 3 times negative 5 will be negative 15, and then x. 2x times positive 1 will be positive 2x. And then negative 3 times positive 1 is negative 3. Again, those two terms combine. Nothing combines with this 10x squared. That'll be negative 13x, and then negative 3. All right, let's do letter B. 6x times x is 6x squared. 7 times x is 7x. 6x times 2 is positive 12x, and 7 times 2 is positive 14. These two terms combine to give us positive 19x and positive 14. All right, last one. 4x times 2x is 8x squared. Negative 1 times 2x is negative 2x. 4x times negative 5 is negative 20x. And negative 1 times negative 5 is positive 5, giving me 8x minus 22x plus 5. All right, so multiplying binomial pairs, whether or not you're using boxes, double distribution, foiling, or whatever, results in trinomials, right? Trinomials, and again, let me just be very clear about this, little color coding, where the first term comes from multiplying the two terms with x, the last term comes from multiplying the last two terms, and then the central term is always found by the O and the I in FOIL, by combining this product with this product. And that's very, very important when it comes to reversing this process in what's known as factoring trinomials. So that's what we're going to do next. Pause the video now and write down anything you might need to. All right, I'm going to clear it out. Here we go. Okay, let's jump into exercise number 3. Consider the trinomial 2x squared plus 13x plus 20. We want to write it as the product of two binomials. So we're going to reverse the process we were just doing. Okay, we're going to factor. Now, this is really an art form. It really is. And we don't want to do any kind of hocus pocus. What we want to do is do what's called guessing and checking. But we're going to make intelligent guesses. So the first thing that they ask us to do in this problem is to fill in these two blanks with the only pair that makes sense. Now remember, whatever goes in this blank and this blank must have a product, and I'm going to do a little erasing here now, must have a product of 2x squared. All right? So what's going to give me a product of 2x squared? Well, what's going to give me a product of 2 will be a 2 and a 1. And what's going to give me a product of x squared will be an x and an x. Typically, we won't write that 1, but I'll put it in here right now. Because remember, the product of those two things is what gives me that. Okay? And that's all we needed to do in letter A, just to think about that. Now, sometimes there'll be more than one possibility. That will make the factoring trickier. But we'll get to it, okay? Now, letter B is interesting. It says, why does it make sense that both of the binomials will be addition? In other words, why is that addition and why is that addition? And what I'd like you to do is I'd like you to pause the video right now, think about what you did in exercise 1 and exercise 2 to try to answer this question, okay? All right, let's talk about it. Well, in a certain sense, we start right here, okay, with that 20. You see, because of the positive 20, they must be both positive or both negative. Because remember, the product of these two things is going to be that positive 20. So either a positive times a positive gives us the positive 20, or a negative times a negative will give us the positive 20. But because the 13x is positive, they must be both positive. Right? If they were both negative, sure, we could get the positive 20. But then when we combine those two like terms, they would combine to be a negative. Maybe a negative 13x, maybe something else. So let's keep going. It now says list pairs of factors that can produce a 20. So whatever goes in these two blanks, it has to multiply to be 20. So, well, we could have 1 times 20, that would work. We could have 2 times 10, that would work. We could have 4 times 5, that would work. And that's it, right? In terms of integers, those are the only positive factors that will multiply together to get 20. Now keep in mind that if we thought that it was a negative, well, we could have these as well. But we're already deciding that they're both positive. Now, here's the part that students dislike the most. In order to truly factor a trinomial, you have to guess and check. So watch. I'm going to make a guess. I'm going to say, I'm going to guess 2x plus 4 and x plus 5. Now, this is a reasonable guess. Let's talk about why this is a reasonable guess. It's a reasonable guess because when I do 2x times x, I get 2x squared. When I do 4 times 5, I get positive 20. Okay? And that's part of it, right? I have the 2x squared and I have the positive 20. But I can tell it's not the correct guess because when I look at this, 4x, and I look at this, 10x, those add to be 14x. And that's not what I started with. I didn't start with 2x squared plus 14x plus 20. I started with 2x squared plus 13x plus 20. So what I need to do is I need to keep guessing until I find the right one. So I know it's not 2x plus 4 and x plus 5. How about 2x plus 5 and x plus 4? Let me try this one. Well, again, it's a reasonable guess because the 2x times x is 2x squared, and the 5 times 4 is positive 20. And then I'll have this, which is a positive 5x, and this, which is a positive 8x. 5x and 8x add to be 13x. But that's correct, you see? So the 13x is actually what we want to get. In fact, I claim that if you make a reasonable guess, now what's a reasonable guess? A reasonable guess is that this times this gives you this, and that this times this gives you this, then all you really have to check is whether or not the linear terms combine to give you that 13x. And in the case of 2x plus 5 and x plus 4, they do. So that is the correct factorization of that trinomial. Now, I know that that's a little bit discouraging because what it means is that you won't necessarily have a method for getting the right answer the first time. That's not a bad thing. That's not a bad thing at all. In fact, a lot of math teachers, and if your math teacher has done this, I'm not faulting them, but a lot of math teachers try to find methods around that, methods that'll give you the right answer the first time every time. But that's not truly, in my mind, the essence of math. The essence of math is trying something, and if it doesn't work, trying something again, and if it doesn't work, trying something again. Okay? So you will get this right if two things are true. Thing one, you're good at multiplying binomials. And thing two, you just stick with it. You keep at it. You persevere. Okay? So that's what we're going to do for the rest of the lesson. We're going to work on factoring trinomials, and we're going to work on persevering. So we'll get more in terms of the idea of how to factor a trinomial. So if you're still a little bit confused, don't worry about it. That's not a bad thing. Anyway, pause the video now and write down anything you need to, and then we're going to get a lot of practice on this, okay? All right, here it goes. Let's get some practice. Okay, now I know on your sheet this is a single sheet, but I want to give ourselves lots and lots of room. All right, we're going to factor these by making intelligent guesses and checks. Okay, intelligent guesses and checks. And we're going to keep factoring them until we're absolutely done. Now, I'm pretty good at factoring because I've been factoring for a long time. So for me, it's almost impossible to write down an incorrect guess, but I'm going to take my shot each time at writing an incorrect one down before we write a correct one down. And eventually I'm going to let you just work on them yourselves. But we do want to try to figure out when they're easy and when they're harder. Okay? So let's jump in to letter A. Make sure I'm on blue because I was on green. First thing I'm always going to do is write down a couple sets of parentheses, and I'm going to look at this. Now I like 3x squared, and the reason I like it, what makes it easy, is that I have only one choice here, 3x and x, right? We'll see somewhere we'll have multiple choices there, and that's a little frustrating. Now we have to figure out what goes into these blanks, here and here. This is where it gets a little bit harder because we've got a -4. Now, whatever goes in those two blanks has to have a product of -4. So what would that be? Well, it could be a +2 and a -2. It could be a +1 and a -4. Or it could be a -1 and a +4. Any of those might be right. So I'm going to glance down real quick, and I looked. Let's give one a shot. Let's do 3x plus 2 and x minus x minus x. I don't think that's right. Let's try x minus 2. Now, this is what I would call an intelligent guess. We don't need to multiply the whole thing out. We don't, because I know 3x times x gives me 3x squared, and I know +2 times -2 gives me -4. We don't need to check those. What we need to check is to see whether or not we've got the correct 11x. That's the real question, okay? So the way we do that is just by doing 2 times x, which is 2x, 3x times -2, which is -6x, and when we combine those, remember we're combining like terms, we get -4x. Well, I need a +11x, okay? So that is not the correct factorization. So what do? We move on. That is not a bad thing, all right? Now, of course, it could be that I just had the wrong order. It could be that it's actually a -2 here and a +2 there. Let's check it quickly. -2x, +6x, add them together, +4x. Nope, I need a +11x. But we're getting closer, right? And the more of these you do, the better at them you will get. So why don't we try a -1 there and a +4 there, all right? That's a -1x. That's a +12x, and when I do -1, +12, I get +11x, and that's right, right? That's our winner. Whoops. So here it is, 3x minus 1 times x plus 4. All right? It took a little while. It took me 3 guesses, but I got there. Now that one was a little bit challenging, right? I'd call that like moderate in terms of the challenging nature. Let's try this one, all right? All right, now take a look at this term first, x squared. Well, really just x times x. Now take a look at this, +10. Now that's a little bit tricky because that could be 1 times 10. It could be 2 times 5. It could be -1 times -10. Or it could be -2 times -5. Now, if you think really hard about the way this is going to work out, it can't be these two because that is negative there, right? If I put positives in both these places, there's no way I'm going to get them to combine to be -7x. So let's try this. Let's go with x minus 1 and x minus 10. Now again, I don't have to check the whole foiling. All I have to do is check this one and this one, and those combine to be -11x. Nope. I need -7x. So let's try this. Let's try x minus 2 and x minus 5. Here I'll get -2x. Here I'll get -5x, and those will combine to be -7x, and that's exactly what I needed. So that is the correct factorization. So hopefully it's starting to make more sense now, right? All right, I just make an intelligent guess, and then I just see if the O and the I in FOIL, if the two linear terms work out to be that center term, that linear term. Okay? Pause the video now, write down anything you need to, and then we're going to keep moving on, okay? All right, here we go. Let's try some more of these. All right, letter C, letter D. I get the feeling C is going to be a little bit easier than D, all right? So why don't you pause the video right now and take a shot at C, all right? If you really feel confident, you can also take a shot at D. All right, let's go through it. Here's why I think C is going to be a little bit easier. I don't think I want. I think I'm going to stick in blue, and then we'll use the green to indicate the correct choice, okay? Here's why I think C is going to be relatively easy. Anytime my leading coefficient is 1, that's my best case scenario. Because then all I'm going to have here are an x and an x. I really like this one because I've got positive here and positive here, right? That means they're both going to be positive. If I have a positive here and a negative here, they're both going to be negative. It's when I have a negative, that's going to be the hardest scenario. But let's think about 21. That's 3 times 7, or 1 times 21. Wow. Well, I'm going to go wrong to begin with, just so that we see an incorrect one. Let's take a look. That's going to be 1x, 21x, and that adds to 22x. So obviously wrong. So let's try x plus 3 times x plus 7. Here we'll have 3x and 7x, and when we combine those, we get 10x, and that is exactly what we wanted. So there is our correct factorization. Stick with it, stick with it, stick with it, stick with it. You can do these. Letter D, that's going to be the most challenging one we've seen so far. So let's tackle it together. And let's talk about why it's going to be challenging. It's going to be tough because the 10 is not a prime number. So the 10 could be either 10 times 1, or it could be 5 times 2. Now, given this choice, given that you have no idea which one it's going to be, I tend to pick the ones that are closer together, the 5 and the 2, rather than the 10 and the 1, but there's absolutely no guarantee, right? This 2 is kind of nice because 2 is prime. We really only have one choice there, 1 times 2, all right? So why don't we do 5x and 2x, and why don't we do plus 1 and plus 2? Again, it's an intelligent guess because 5x times 2x is 10x squared, and 1 times 2 is 2. So 1 times 2x is 2x, 5x times 2 is 10x, and those add to be 12x. But I need 9x, so it's not right. So why don't we flip-flop and try 5x plus 2 and 2x plus 1, and apparently give myself a lot of parentheses. All right, well, 2 times 2x is 4x. 5x times 1 is 5x. Add them together, and you get 9x, and that's what I needed. Okay. Factoring trinomials. You probably see now why I consider this to be the most challenging type of factoring, because what it takes more than anything else is perseverance. It takes you looking at the problem, taking a shot at it. If it doesn't work out, whatever. You cross it out, you move on. You wasted a little time, you wasted a little paper. I know time is valuable, but what's more valuable is learning the trait of perseverance, right? Being able to just persevere through until you know you have the right product. All right, anyway, enough of my soapbox. Pause the video now, take a look at what we did, and let's do a couple more. All right, clearing it out. Let's keep going. All right, letter E, letter F. These are getting harder and harder as we go. That's okay, we like it. Let's do letter E together, then maybe you do letter F. All right, letter E is a particular challenge. And I went in green again. Anyway. Here's my blue. All right, it's a particular challenge because again, 8 can be thought of as two ways, 8 times 1 and 4 times 2. Again, which one is it? I'm not sure. I think I'll go with 4x and 2x. Now, take a look at this. Here we've got a positive 9. Here we've got a negative 18. All right, 9 can be thought of as 1 times 9 or 3 times 3, but they're going to both be negative because that center term is negative. So I'm either going to have negative 1, negative 9, or negative 3, negative 3. I love negative 3, negative 3, and the reason that I like negative 3 and negative 3 is because it really doesn't matter which one I couple it with. But let me go with negative 1 and negative 9 first. All right, let's do 4x minus 1 and 2x minus 9. Again, it's a reasonable guess. 4x times 2x is 8x squared. Negative 1 times negative 9 is positive 9. But now let's check. We get negative 2x there. Ooh, negative 36x there. When I add those together, I get negative 38x. Now, it doesn't mean I should throw out the negative 1 and the negative 9, or the 4x and the 2x. In fact, it could be that it's really just this. Maybe that 1 and 9 are flip-flopped. Well, let's try this. Negative 18x, negative 4x, add those together, we get negative 22x. Still not right. Shouldn't throw out the 4x and the 2x. I'll throw those out after the next one if I need to. Let's try 4x minus 3 and 2x minus 3. Here I'll have negative 6x. Here I'll have negative 12x. When I add those two together, we get negative 18x, and that's my winner. Right? So 4x minus 3, 2x minus 3. Okay, I can't emphasize enough how much you have to make intelligent guesses. And by intelligent, you have to make sure that these two terms have this as a product and that these two terms have this as a product. If they don't, then the whole method breaks down, the entire method. So what I'd like you to do now is pause the video and take a shot at letter F, okay? One of the things I really like about factoring is that you should know whether or not you're right. All right, so let's jump into it. All right, I like 2x squared. It's kind of where we began. It's got to be a 2x and an x. Now 33, and keep in mind that negative, so one's got to be negative, one's got to be positive, don't know which. But 33, there's not a lot we can do with that, right? It's 3 times 11, so it's either negative 3 and 11, or it's positive 3 and negative 11, or it's 1 times negative 33, or it's negative 1 times positive 33. Whew. So there's a lot of choices here, but you know, why don't we start with one that's wrong? I don't know why, but I feel the need not to have the right one right from the beginning. So I'm going to do 2x plus 3, x minus 11. So I do that, I get 3x. I do this, I get negative 22x. I combine them together and I get negative 19x. Nope, I need positive 5x. All right, let's try another one. 2x, x. Why don't we go with negative 3 and positive 11? Let's see what happens there. Here I get negative 3x. Here I get 22x, and that gives me positive 19x. Still not right. All right. Well, I'm not ready to jump yet. How about we put 2x, oh, we haven't put the 11 over here. Why don't we put the 11 here and put a minus 3 there. That's going to give me positive 11x, negative 6x, and when I combine those, I get positive 5x, and that's what I needed. 2x plus 11, x minus 3. You know, if you really think about these are like puzzles. You know, not quite like Sudoku or those kind of things, but they're puzzles, right? You know pieces of the puzzle. You know parts of these products. The question is, how do you have to arrange the puzzle pieces so that center term comes out correctly? All right, I'm going to clear this out, so pause the video now and write down anything you need to. Okay, here goes. All right, we're going to do one more set and then we'll be done with the lesson. All right, I'd like you to pause the video now, and I'd like you to try both of these, and then we'll go through them both. All right, let's do it. So, you should have found that one of these was relatively easy, and one of them was a little bit harder, but probably not as hard as the last one. This one should have been relatively easy. X and X. Because that's a negative there, and that's a positive there, the two things here have to both be negative. All right? Now, 12, that's a little bit annoying. It could be negative 1 times negative 12. It could be negative 2 times negative 6. It could be negative 3 times negative 4. All right? Now, you might even have developed enough of a sense of this to understand which one's correct, but let me, again, do an incorrect one. Right? Here I'll have negative 3x, negative 4x. Those will combine to be negative 7x. Nope. But if I do x minus 2 and x minus 6, we'll get negative 2x, negative 6x. Those give me negative 8x, and that's my winner. Let's see if I can remember to change my pen back into blue. See, I did. X minus 2, x minus 6. Now this one's a little bit harder, but the 7, the 7's not too bad. Right, since 7 is prime, we know that has to be a 7x and an x. Now this is a negative 8, so I'm going to have either 1 times negative 8, or negative 1 times positive 8, or 2 times negative 4, or negative 2 times positive 4. Whew. So let's try one. Let's try 7x minus 2 and x plus 4. Negative 2x, positive 28x, and that gives me positive 26x. Now wait a second, I'm supposed to get a negative 26x, and I got a positive 26x. So if these had been reversed, had this been positive and had this been negative, it would have been right. I know how to do that. I can get that by changing this into a positive 2 and this into a negative 4, because then that will give me positive 2x, negative 28x, combine to be negative 26x. There we go. All right. So, pause the video now, think about what we did in these last two problems, and then we're going to wrap it up, okay? All right, here we go. So today was more or less a lesson in perseverance. All right, how do we take a trinomial and figure out the two binomials, if there even are any? There's some trinomials that are known as prime. You can't even find two binomials that multiply to be equal to that trinomial. All the ones that we work with, you will be able to, so don't give up. But it's really just an issue of guessing the binomials, making intelligent guesses, and then multiplying them out to see if they have a product that's equal to the trinomial that you started with. On the homework, I want you to keep at it, keep at it, keep at it. Use extra paper, use extra scrap paper, until you get the right pair of binomial factors. All right. For now, though, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kurt Weiler, and until next time, keep thinking,